Dear students, this is a video assess for you in order to solve our assignment questions. This is your first question. It's from stability analysis problem, and you can read the question. In your question, the unit weight of concrete or the material with which the dam is constructed is given in 2.4 ton per meter cube. Instead of kilonewton per meter cube, it is given in ton per meter cube. Similarly, unit weight of water will be in 1 ton per meter cube. Also, it is given that the unit shear stress of concrete, that is Q, shear strength parameter small q, is given to you in 14 kilogram per centimeter square. Okay. While doing this problem, this was the table that we used in our previous problem that I discussed with you in our lecture number 2. So here the change will be, instead of this force unit kilonewton, it will be ton. Similarly, for vertical force also, it will be in ton, and the lever arm from toe will be in meter. No change for that. And the final moment you are getting will be in ton meter instead of kilonewton meter. It is the main difference between this particular problem and your current assignment question. Also, this is the figure of the gravity dam that given to you. All of you see the figure. In figure, the various parameters of gravity dam, like upstream water level, downstream water level, distance of gallery from heel, these three parameters are varying for all of you. So corresponding to your roll number, you identify the condition and then try to solve the problem. Another change is that you see the upstream face of the dam. See, the upstream face of the dam is not vertical, but it is inclined. So, while doing or while considering the types of forces, the very first force that you have to consider, the self weight of the dam. While doing the problem, the self weight of the dam you can divide to this triangle, this as a rectangle, and this as a triangle. Also, since the upstream face of the dam is inclined, you have to consider the weight of water column at the upstream side. For that, you have to take the self weight of the water column at the upstream direction. In order to take the self weight of upstream direction, in order to take the weight of the upstream direction, you see, you have to take the weight of this upstream side of water from here. You have to take up to where you have the upstream water level. Suppose you have upstream water level up to here. This is actually the top of the dam. Suppose you have upstream water level up to here. So you take up to here, then you can divide that area into a triangle and a rectangle. Then you calculate the self weight of the water. Similarly, you are having tailwater also. There also you have to take the self weight of water at the tailwater condition or at the downstream condition. Now, while doing the stress calculation, you know that this is our point heel and this is our point toe. While doing the stress calculation, for example, if you refer our topics or equations. See, the major principal stress at toe, you have the equation. The major principal stress at heel, and you have the equation. Okay, here this angle alpha, that is actually the angle, here the vertical makes with the upstream inclined portion of the dam, means the same angle theta will be applicable in this particular equation. That is the case of heel. While you take the case of downstream side, see, you have to find this particular angle that is same as phi, and you have to put that angle phi for the calculation here. I think you remembering the term P dash and capital P. Small p dash is unit weight of water into small h. Capital P is unit weight of water into capital H. So, while doing the calculation or stress calculation at heel, you have to consider this angle as the angle made by this inclined portion of upstream side with the vertical, that is same as theta. That is the point that you have to take care while doing this problem. While doing the remaining steps, see, there is a term small q, and small q is applicable here, you know, and small q value in question also it's given to you in kilogram per centimeter square, but everywhere here the unit will be in ton and meter. So you convert this kilogram per centimeter square to ton per meter square for further calculation at this particular step. I think this is all about question number 1, the stability analysis question that you can do yourself. Each one of you have to see the data sheet where the upstream, downstream and distance of gallery from heel condition is varying. Based on your roll number, you have to put the value and do the calculation. Question number 2 is describe and brief the functions of basic things, shaft, key, water stops, like that. You can refer either BC Punya or using any online sources you can do the assignment. And your question number 3 is explain the functions of gallery of a dam and classify various types of gallery. Here also you can refer BC Punya or any other online sources. So you can do question number 1, 2 and 3. Thank you.